guys, so here we're going to introduce Table G, which is solubility curves. You'll need your notes, your calculator, and you will definitely need Table G because we're going to be writing all over it. Alright, so here's Table G. On the x-axis, we have temperature in degrees Celsius. On the y-axis, we have solubility, so it's grams of the solute per 100 grams of water. And we have a ton of compounds here. Alright, so each one of those compounds has their own little line that represents them. So it's showing here that for each compound will dissolve in water, or a different amount of each compound will dissolve in water, and it's based upon temperature. Most of these lines are going up. So we have all of these that are increasing. So the solubility, meaning how much will dissolve in water, will increase with the temperature. Even over here, that little NaCl is still going up. We see this whenever we're making any sort of like Kool-Aid mix, for example, or Crystal Light. Take a packet of that substance, dissolve it in water. The higher the temperature of the water, the more of it will be able to dissolve. So all of these are able to dissolve with higher temperatures, except for these little guys, right there, here, and here. In fact, when you increase the temperature of the SO2, the NH3, and the HCl, they actually decrease in solubility. So again, most of these will increase in solubility with an increase in temperature, but these three will actually decrease in solubility when you increase the temperature. All right? So let's talk about what this all means. Say, for example, you have a substance. They say how much of KNO3 can dissolve in 100 grams of water at a certain temperature. So if they said KNO3, I'm going to find KNO3, which happens to be right here. And when you're taking the regions, you can go ahead and highlight or write all over these reference tables. We recycle them, so don't even worry about writing on them. Feel free to. Okay? So we can determine how much will actually dissolve in there. So say, for example, they give us a scenario that says 40 degrees Celsius. So I have 40 degrees Celsius right here. And I want to know how much KNO3 can dissolve in there. So this point that falls on the line, that is when it's saturated. So if the point falls on the line, it's saturated, meaning that no more of that solution or no more of the solute can fit right in. It also means that the rate of dissolving is equal to the rate of crystallization. So for saturated, rate of dissolving, meaning how well that dissolves in water, is equal to the rate of crystallization. That's an S. So this is an equilibrium because we have an equal sign. It's an equilibrium. So it just so happens at 40 degrees Celsius, 68 or 67 grams of KNO3 will dissolve in 100 grams of water. Say they ask us what will happen if you put in 80 grams of KNO3. And I'll get rid of this little line right there. I'll put that point back in. So we said 80 grams. 80 grams here actually falls above the line of where KNO3 is at 40 degrees Celsius. So we have to make sure we stick to that same temperature, 40 degrees Celsius. That is called supersaturated. So when supersaturated, no more solute will dissolve. All right? So let's say they give us another amount. I'm going to get rid of some of these lines. I'm still at 40 degrees Celsius. But say, for example, they say 30 grams. So here, since this point falls below the KNO3 at that same temperature, at 40 degrees Celsius, it's considered unsaturated. Meaning you can still put in more of that solute. In fact, you can put in all of this amount of solute in there in order for it to finally become saturated. So they might also ask you that question. If given 30 grams of KNO3 at 40 degrees Celsius, how much more solute can be added for it to become saturated? So you take whatever this was, whatever the saturated point was. So say it's 67 grams. And here we said we only put 30 grams in. So the difference is 37 grams. I can put 37 more grams of KNO3 into that container at 100 grams of water, and it can still be saturated. So if I put 38 grams, then it would become supersaturated because it would fall above the line. So 37 is that happy point where it becomes saturated. Other things you need to look out for, so I'm going to kind of clear off this, is the 100 grams. Sometimes they'll ask about 50 grams or 200 grams. So, for example, we'll still use KNO3 because it's there. They'll ask how much solute can be dissolved, or how much KNO3 can be dissolved in 50 grams of water. So here I'm at 10 degrees Celsius. So here I'm going to find 10 degrees Celsius and there. So that's about 24 grams of KNO3 per 100 grams of water. And I know it's 100 grams because I'm reading it off the table. Say, for example, they wanted 50 grams. Well, you know you're cutting this in half to make that 50. You've got to cut this in half to make that 12. So it'd be 12 grams of KNO3. Say if they wanted 200 grams instead of 100 grams. So if they wanted 200 grams of water, this is times 2, so this one would be times 2. So you'd end up with, you can put 48 grams of KNO3 in 200 grams of water. So what's the solubility trends? Most compounds increase in solubility with an increase in temperature. The exceptions are HCl, SO2, NH3, and pretty much any gases. We know this in the summertime. So if we take a can of soda, put it outside in the heat, it actually ends up, and another can of soda inside where it's cooler, there's actually going to be less gas bubbles inside of that soda when it's hotter out. So pretty much gases will decrease in solubility when we increase in temperature. I mean, there's going to be less gas bubbles inside of that soda or the solution when we increase the temperature. All right, to summarize, check the X and Y axes. Make sure that you're looking at the correct axes and points. If a point's above a line, it's supersaturated. If the point's on the line, it's saturated. And if a point is under the line, it's unsaturated. So remember, under, unsaturated. That might help you out as well. And also check to make sure that, or always remember that it's based on 100 grams of water. So if they double the amount of water, double the amount of solute. If they cut it in half, you should decrease the solute by half. So let me know if you guys have any questions. Take care.